So I'm Mike Houston. I'm from Nvidia, so we're traditionally known as a GPU manufacturer. So I actually do a lot of work on optimizing mobile and cloud infrastructure using the horsepower of GPUs. So you probably don't know, but GPUs are actually deployed in production in a bunch of data centers today. They're just not generally talked about a whole lot. So kind of a quick example of why GPUs came into play. So in Shazam, sort of began to hit it big and needed to ramp up production. They couldn't deploy servers fast enough. So one way to fix this is to drop high horsepower processing in their nodes. So they're able to get a 3x benefit right off the bat by dropping GPUs in. So reminder what a CPU is: optimized for very low latency access and does very well running out of cache, and has a lot of control logic to be very, very good at out of order and speculative execution, so really branchy code. GPU, on the other hand, is a massively parallel processor, massively threaded, vector core fundamentally, optimized for data parallel computation, and its architecture is very tolerant of memory latency, which means we get a high, very, very high percentage of our memory bandwidth. So if you look at the comparisons between these cores, on face we have 6 times the bandwidth, roughly. In practice, closer to 10 times the bandwidth on real applications, and 8 to 10 times the flops. So tremendous amount of horsepower that you can use here. So they're PCI attached things, so you can slam them in servers and off you go. So here's some examples of folks use GPUs in production. So you have Adobe that uses us for image analytics in the Creative Cloud. You have Flickr using us for image classification, deep neural networks. Baidu uses GPUs to accelerate speech and image recognition. You have IBM that does back-end Hadoop acceleration using GPUs, real heavy compute and scale out. You have Netflix building recommendation systems. You have Yandex doing search rankings. There's people doing cryptography, software-defined networks, a bunch of other things. Anything that needs high density compute and low latency. So we can't really call this acceleration as a service. It makes the marketing people unhappy. If you call it SaaS and remove the S, it's not a great one. So they have lots of acceleration potential, very hard to use in the data center for people that aren't used to hardcore GPU programming. So what we're working on is to get things inside more of a REST API infrastructure to allow you to very, very easily deploy GPUs to accelerate things. So the other option is to call this GPUs as a service. That doesn't work either. Marketing guys don't like that one. So quick example, we've been doing a lot of work on very, very high-speed image resizing. So we're actually fast enough that instead of doing your batch resize, we can actually resize on the fly from 5 megapixel images, or we can use this as a back-end solution for your normal ingest to build your resize stack. So we did it as a REST service because it plugs into lots of different scenarios, be it a CDN or back-end solutions or mid-end or at the edge, and even on the phone device that have accelerated GPUs. The main thing is to wrap all your management so you can wrap the resources. You have to get things on and off the GPU. So we actually wrote a web server from scratch because we couldn't find one that had met our needs. So we actually are C10 capable. So getting things in and out of the GPU, you can actually do 10,000 transactions per second per GPU. And we have hard resource isolation. We're actually much less than 1 millisecond. We can actually get down to 40 microseconds to actually issue a transaction through the GPU. So for resizing, you play to things strength. The CPU does the server code, the GPU resource allocation scheduling, and the parsing and decoded JPEG, because that spec sucks for decoding. And the GPU does all the other heavy lifting, actually including the resizing and encode. We rolled our own server because the event-based servers are really, really fast, but don't let us actually control the resources underneath. So we had to build a hybrid system that allowed us to get the benefits of event-based processing, very high throughput, and control the resources underneath. So if you want to roll this yourself, here's the easiest way to do it. You can actually grab Boost Osio. Everybody makes fun of it, but if you actually take their server example, on a server that Nginx gets 100,000 requests per second, that code will actually get 68,000 requests per second without much effort. So it's actually pretty fast, so take a look at it. Lots of lessons learned. The HTTP specification is nice, but then there's reality when you have to interact with everybody else. Network stack tuning is annoyingly still important. Different tools hit you differently. So we thought we were good with Siege and Apache Bench, and then we got hit with Iago, and Iago issued a denial of service attack against us on EC2. How fast are we? We're pretty fast. So compared to ImageMagick or even GraphicsMagick tuned with OpenMP, we're somewhere between 5 and 10x with a single GPU. The big one is the latency there. For 5 megapixel image, we can resize a 5 megapixel image in 150 milliseconds versus 1.7 seconds on a CPU. So we're working to actually make a more general framework to allow other people to plug in GPUs and use them as a REST service. Image resizing is the first one we're working at. And we're also looking to get better integration of GPUs into all the frameworks you guys know and love to make them more GPU aware so it's easier for you guys to get access to accelerators. And I got my slide timing wrong. Go. So you can actually contact us. That's supposed to be sign up, but you can sing to us if you want. But there are GPUs in Amazon, so most of you won't have GPUs in your data center, but so you can contact us or find me if you're interested in imagery sizing or GPUs in general in your data center. All right, thanks.